Good morning. This is Arvind. So today we will discuss about the pointers. So before going into this particular concept of pointers, we need to understand what is a pointer, what is the necessity of a pointer, why we are going for the pointers concept. So here we know that we have so many types of user-defined data types or derived data types. So pointers is one such of user-defined data type. For example, we have seen functions, arrays, structures, unions, and enumerated data types. All these are nothing but they are derived data types. So pointers is also one sort of derived data type. And why we need to have pointers? What is the need for pointers? So the use of pointers help us with a high degree of flexibility in managing the data knowledge of memory organization. As we know that memory organization plays a very important role for understanding the concept of memory. Now let us consider or let us discuss the organization of memory before stepping into the concept of pointers. So memory is organized in the form of sequence of bytes sized 8 bits per byte. So here a byte is a basic storage and accessible unit in the memory. Each byte in the memory is associated with a unique number, and this particular unique number is called the address. Suppose that we have a 64 KB of memory. The meaning of 64 KB means 64 into 1024 bits. 1024 bytes, sorry. Kilo means 1024. So 64 KB means 64 into 1024 bytes. So 64 into 1024 is 65,536 bytes. So here the memory can be viewed as an array of locations of size 65,536 with the subscripts ranging from 0 to 65,535. So here 0 represents the address of the first location, 1 represents the address of the second location, and henceforth the location is identified as the last address as 65,535. Now here, since we are storing the memory with a number called address and we can access. So based on the type, for example, if it is a character, it is going to occupy 1 byte. So 1 address memory location. So if it is an integer, depending on the compiler what you are using, it can be of integer can be of 2 bytes or 4 bytes. If it is 4 bytes, it is going to occupy 4 address. So if it is starting at 0, 0, 1, 2, 3. So it is going to occupy the memory from 0 to 3 for storing one integer variable. Okay. So in this fashion, we are going to allocate the memory. So here, in this particular pointer concepts, in this chapter, we will discussing about the pointer concepts, pointers as functional arguments, pointers and strings, character pointers and functions, address arithmetic, pointers to pointers, pointers and arrays, dynamic memory management function. But whereas in this particular session, we will discuss the first two objectives, that is the pointers concept and pointers as functional arguments. That is, here we will learn or understand the concept of pointers and how to use the pointers, and we will see how to declare, define and initialize the pointers, and how to write the programs to access the data through the pointers, and to use pointers as parameters and return type. That is pointers as functional arguments. So here, coming to the pointers, let us see what is the definition of a pointer. So here a pointer is a user-defined data type that creates a special type of variable which can hold the address of the primitive data types like character, integer, float, double, or user-defined data types like functions, pointers, etc., or derived data types like arrays, structures, unions, and enumerated. Here the example for representing the pointer is int asterisk ptr. This asterisk symbol is called as an indicator symbol. So we are going to use this indicator symbol, that asterisk symbol, to represent that it is a pointer. So what this pointer is going to, pointer variable is going to hold, means the pointer variable is going to hold the address of another variable as its value. Okay, so any variable in a C programming language has two things. One is the value of the variable and the address of the variable where it is stored in the memory. Similarly, here the pointer ptr will also have the value and it will also have the address. So here pointer ptr value, what is the value means? It is the value of the address of another variable. And here int, what does this int define? So int is not the type of the pointer variable. Int is the type of the variable in which the pointer is going to hold. So whatever the pointer variable is there, that pointer variable will be pointing to some other variable. So that variable's type is the int. So here, let us see the meaning. Suppose, for example, int pointer ptr, and if my a is float, a is equal to 5, I cannot write int pointer ptr. I have to write float pointer ptr. Since my a variable is of type integer, so this pointer variable will be also of type integer. I hope you understood the concept. So what is the data type of pointer variable? Means the pointer variable will have the data type of the pointer variable will be the data type of the variable which it is going to, that particular pointer variable is going to hold. So here I have defined the variable a, which is of type integer, and I have assigned a value of 5. So now I have created another pointer variable, and this pointer variable is having the value, that is ampersand a. So a is the value and ampersand a is the address of a. So the pointer variable always holds the address of the variable. Now let us see this with more clarity. So here I have defined a variable int a is equal to 5. So what is a? A is the name of the variable. So a is the name of the variable. And what is the value of a? The value of a is 5. And this particular a variable need to be somewhere in the memory. So the memory address of a is 1025. Now I have defined another variable ptr which is of type pointer variable. So what is PTR? PTR is the name of the pointer variable, and its address is 5000. Now what this PTR is holding? PTR is holding the address of A. So what is the address of A? 1025. That's the reason here the value of the pointer variable is nothing but it is the address. So it is going to hold the address of the other variable. Now let us see how we can represent the pointer variables, and let us see the concepts that are related to the pointer variables. So here a variable where it will be stored in the memory is decided by the operating system. You cannot say that you need to go and allocate a memory for particular variable at a particular place. So that will be, the compiler will take care of where to allocate the memory based on the situation. So it's not mandatory that all the time it will be allocating the same place or same location for that particular variable. So we cannot guess at which location a particular variable will be stored in the memory. Now here, when the pointers are built on three underlying concepts which we are going to see now. So here we are going to see what is called pointer constant, what is called pointer value, and what is called as a pointer variable. So let us see the first one, that is pointer constant. So pointer constant, memory address within a computers are referred to as pointer constants. So we, as the address we cannot change, we can only use them to store the data value. So they are like our house members. So what are pointer constants? Memory addresses within a computer are called as pointer constants. Okay. Similarly, we cannot save the value of the memory address directly. So we can only get the address of the variable by using the symbol or by using the operator ampersand. So ampersand is the address operator what we are going to use to fetch the address of any variable. Okay, so the value thus obtained is known as pointer value. So the pointer value may change from one run of the program to another. As I have said earlier, the memory will be allocated by the compiler. So always it is not going to allocate the same memory location for a particular variable. So the compiler, based on when we are running, based on the free memory location, it is going to automatically allocate the memory address. Okay, now let us see what is a pointer variable. Once we have a pointer value, it can be stored in another variable. So the variable that contains the pointer value is called as a pointer variable. So let us see this with an example. So here, let us see what is pointer constant, what is pointer value, and what is pointer variable. So here, A is the pointer constant. So we cannot, once I have said pointer is equal to ampersand A, so this particular pointer is going to flow to the address. So ampersand A. So this particular address 1025 is a constant. So this is what is called as a pointer constant. Then what is pointer value? So let us see what is a pointer value. So the pointer value is nothing but it is the address of a variable. So here we see that A is the pointer constant, 1025 is the pointer, what is it? It is pointer value, and the pointer variable is this 5. The pointer value is this 5. So pointer constant is A. Pointer variable is 1025 and pointer value is 5. So this is the concept what we need to understand before going into the pointers concept. So the benefits of using these pointers is pointers are more efficient in handling arrays and data types. So instead of declaring an arrays, we can define the pointers. The difference between array and pointers is arrays we are going to store in a continuous memory location. So it is an homogeneous, whereas a pointer is heterogeneous. So for example, a of 0, a of, if I have declared int a of 10, which is an array. So A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, all these things will be in a continuous memory location. Whereas if I am defining it in the form of a pointer array, then they are heterogeneous. So dynamically, based on the availability of the memory, it is going to allocate the memory to that particular variable. So all will be, they can be continuous or they can be at different memory locations. So these pointers concept generally we are going to use in stacks and queues. So pointers can be used to return multiple values from a function via function arguments. That is another benefit of using pointers. So the use of pointer arrays to character strings result in saving the data storage and space in the memory. Pointers allow C to support a dynamic memory management, as we have said that it is going to allocate the memory dynamically, that is at the runtime. Pointers provide an efficient tool for manipulating dynamic data structures such as structures, linked list, queues, stacks, and trees. And pointers reduce the length and complexity of the program. So they increase the execution speed and thus reduce the program execution time. Speed will be increased and time to execute that particular program will be decreased. So these are the different advantages of using the pointers. So in every C, every variable in a C must be declared for its type. Since pointer variables contains the address that belongs to a separate data type, they must be declared as pointers before we use them. So the syntax for declaring a pointer variable is data type, pointer, pointer name. So this pointer name is the name of the pointer variable, and data type talks about the type of the data variable where this pointer name is going to point. So this tells the compiler three things about the variable pointer name. That is, the indicator symbol, that is the asterisk symbol, tells that the variable pointer name is a pointer variable. And pointer name needs a memory location. And pointer name points to a variable of type data type. That example int pointer p. So here p is an pointer name, and pointer p, it says that it is an pointer variable. So it is pointing to which variable? It is pointing to a variable which is of type integer data type. So the type of the variable to which it is pointing is of type integer. So that is what is the data type. So it is not the data type of p, it is the data type of the pointer variable to which it is pointing. So suppose if p is pointing to a floating point type, then we need to write float p. If it is pointing to a character variable, we have to mention char pointer p. So here we are going to declare the pointer variables. So here the important thing, the pointer that points to number of variable contains a special null pointer constant. That is the one of the key thing that what you need to remember. So if the variable is to be used as a pointer, it must be declared such that a pointer declaration constant of data type and an asterisk and the variable name. So here we can declare it as data type pointer var1 comma var2 comma var3 semicolon. So we can declare any number of pointer variables. So where data type is any valid data type of var1, var2, varn are the names of the pointer variables, and the declaration tells the compiler that var1, var2, so on up to varn are used to store the address values as we are representing them as a pointer variables. So data type pointer var1 comma pointer var2 comma pointer var3 so on up to pointer varn. What they talk is they say about the different pointer variables that are pointing to of type data type, and these will hold the address of the variable which is of a type data type. Okay. Now let us see how we can initialize a pointer variable. So the process of assigning the address of variable to a pointer variable is known as initialization. So once a pointer variable has been declared, we can assign the variable. So we can assign the variable at the time of declaration, or we can define it separately. So if I want, I can write int pointer p, or int pointer p is equal to ampersand quantity. So both are valid. So I can assign the values to the pointer variable separately, or I can assign the variables at the time of declaration itself. So here, what is pointer p? Pointer p is a pointer variable which is going to hold the address of another variable. So here, that other variable what I am supposing in this particular example is quantity. So int quantity. So quantity is a variable, name of a variable which will have some value, and it will be allocated in somewhere in the memory. So this quantity will have value and the quantity will have address. If I am not going to assign the value to the quantity, it is quantity will have the garbage value. Quantity will have the garbage value, and the type of the quantity is of type integer type, and it will be allocated at some memory at some address. That address the compiler will know. To know that address of the quantity, we need to put an ampersand symbol. So here I have declared int pointer p, and I have declared int pointer p is equal to ampersand quantity I can write, or else I can declare int pointer p is equal to ampersand quantity. So both at the same. See here, int pointer p ampersand quantity. So what is quantity? Quantity is a variable which will be having that at some address. So that address will be stored in this particular pointer variable. Now suppose I can assign the value to the quantity. I can directly say quantity is equal to 89. I can say pointer p is equal to 89. So here, this is where I am assigning value to the pointer variable, that is address of quantity. And this is how I am assigning value to the variable. So here P is equal to ampersand quantity is the address. So here star P will have P will have the address of the quantity that I don't know. It is some value where the quantity is being assigned a memory location by the compiler in primary memory. And the value of quantity, I can assign the value to the quantity. So I can write directly quantity is equal to 89. Instead of this, I am doing pointer P is equal to 89. This concept already we have seen in call by address. We have seen call by address and call by reference program. Already we have seen this particular example. So here int x pointer, see both I am assigning. So int x comma pointer p. So instead of declaring the variable x and a pointer variable p separately, I can even declare the variables in this fashion also. So this is how I can assign values to the pointer variables and values to the variables. Now let us see pointers as functional arguments, that is call by address or call by reference. So pointers provide a two-way communication between the service request and service provider. It is achieved by passing the address of the actual parameters instead of their content. So any modification done to the formal variables in the function will be automatically reflected in the actual parameters when they are passed by the address. So here what are actual parameters? The parameters that appear in the function calls. So calling function, whatever the parameters we see, those parameters are called as an actual parameters. Then what are formal parameters? Formal parameters are the parameters that are found in the function declaration or called function. So here let us see the same example program for swapping of two numbers. So here in swapping of two numbers, we will see how we are going to assign the values. So here I have main function. In the main function statement, I have used swap ampersand x comma ampersand y. So here assigns address of the actual parameters to the formal parameters. So x and what are x and y? X and y are the variables. So here x and y are the variables and x and y will be allocated some memory when we compile the program. So that memory address, so address of x and address of y, so these are called as an actual parameters. So I am address ampersand x and ampersand y are the address. So using the address, what I am doing, I am calling a function swap. So here the x value will be placed, so pointer variables can hold the address of the variable. So I cannot pass to int px or int py. So to hold the address, it should be a pointer variable. So this particular pointer variable px will hold the address. So these are called as an actual parameters and these parameters are called as an formal parameters. So assigning the address of the actual parameters to the formal parameters which are of type pointers. Here, however, they are manipulated differently. In main function, the parameters are accessed directly with their names, whereas in swap, they are accessed using the indicator operator. So this asterisk, we are going to call it as an indicator operator. So in swap, accessing the contents of the memory location pointed by the variable px actually access the content of the variable x. So here, even though it looks that as if we are accessing the variable px, but here we are not accessing the variable px. We are accessing x. So instead of px, we are actually accessing the content of the variable x. Similarly, accessing the content of the memory location pointed by the variable py actually accesses the content of the variable y. Hence, swapping the contents of the memory using pointer variables px and py along with the indicator operator will in fact exchange the content of the actual parameters of x and y. So here that we can show here. So I have accepted two variables. The variable x is having 20, y is having x is having 10, y is having 20. The address of x is 2000 and the address of y is 3000. A is the variable name, b is the variable name. Sorry, here it is not a and b, it is x and y. X is the variable name and y is the variable name. So here x is having the address 2000 and y is having the address 3000. So here when I swap these variables, they are pointed towards the pointer variable. So when they are pointed, here it is the name what I have given. Let me show you px. So here it is not a, it is px. The px address is 3005 and py address is 4000. So now the px variable is pointing to the address 2000 and py variable will be pointing to the address 3000. So when I swap the values, automatically a value will be changed to 20 and b value will be changed to 10. So this is how we are going to use the pointers as functional arguments. Thank you. Thank you very much. So we will see the remaining part in the next session. Thank you.